Hello viewers, welcome again to my channel, Second Math Hub, the solution to your math problems. This is lesson 2 of indices, and in this lesson we are going to look at laws of indices. So for us to be able to solve problems in indices, there is the need for us to look at the laws of indices. Now basically indices has three laws. Indices has three laws, and let's begin with the first law. Now, the first law is saying that, let's say we have an index, a exponent m, multiplying another index with the same base. So let's say a exponent m. All that this law is saying is that anytime we come across a situation like this, whereby two indexes are multiplying with the same basis, just write one of the bases and then add the index. So let's look at an example. So let's say we have 2 index 3 multiplying 2 index 2. So all that this law is saying is that because the bases are the same and they're multiplying, we pick one of the bases, we add the index. And what is 3 plus 2? That is 5. Why is this law so? Okay, so let's use this same example. So 2 index 3 times 2 exponent 2. Now 2 index 3 can be written as 2 multiplying itself 3 times. And then 2 exponent 2. That is 2 multiplying itself 2 times. So when we remove the brackets, we have 2 multiplying itself 5 times. And from our first lesson, how do we write this expression in index form? So you can see that 2 is being multiplied by itself 5 times. And this could be represented as 2 index 5. Now, let's look at the relationship between the indexes. Here the index was 3, the index was 2, and then for the final answer, the index is 5. So 3, 2, giving us 5. What basic operation must be placed between 3 and 2 to get to 5? So clearly that is addition, because 3 plus 2 is 5. So all that this law is telling us is that anytime we get a situation like this, we shouldn't waste our time expanding them into this form before we get the final answer. Because the bases are the same and then the indexes are multiplying, we just write one of the base and then we add the index, and that is the answer. So that is for the first law. So with this, can we also try this example? Okay, so let's try this one. 3 index 3 multiplying 3. So see that the bases are the same. So what do? We add the index. What is the index here? The index here is 3 plus, what is the index here? So there is an index of 1. So take notes. In indices, anytime you see a number without any index, there is an index of 1. But we don't write it. So there is an index of 1 here. And this is simplified as 3 index 4. Can you also try this one? Another one. This time we have 5 index 6 multiplying 5 index 10. Again, the bases are the same. They are multiplying. So we pick one of the bases, we add the index, and we end up getting 5 exponent 16. So now we are moving to the second law of indices. The second law of indices, this is what the law says. Let's say we have an index with a base of a. So let's say a exponent m divided by an index with the same base, but this time a different index. All that this law is saying is that anytime the bases are the same and then they are divided, you write one of the bases and then we subtract the index. So example, so let's say we have 2 index 5 divided by 2 index 2. So because of this law, we see that the bases are the same, at the same time they are divided. So we write one of the bases, we subtract the index, and this will give us 2 index 3. So again, why is this law so? So now 2 index 5 divided by 2 index 2 could also be written in this form. So now let's expand. 2 index 5 means that 2 is being multiplied by itself 5 times. And then 2 index 2 means 2 is multiplying itself 2 times. So we can cancel out. So these 2 can cancel out these 2, and then these 2 also cancel out. So we are left with 2 multiplied by 2 multiplied by 2. How do we write this in index form? So this could be written in index form as 2 index 3. Again, let's look at the relationship between the indexes. 2 exponent 5, so we have 5, 2, and then 3. So 5, 2, and then we had 3. Which operation sign should be placed between 5 and 2 to give us 3? So clearly the operation sign is minus. So 5 minus 2 is equal to 3. So because of this, all that this law is telling us is that there is no need for us to spend much time to do this operation before we get the answer. Anytime the bases are the same and then they are dividing, just write one of the bases, subtract the index, and that gives you the answer. So that is for the second law of indices. So they call it the quotient law. Others also call it the division law. So that is for the second law of indices. Okay, let's also look at the third law of indices, also known as the par law. So what does this law say? What this law is saying is that, let's say we have an index form a exponent m, and then this a exponent m also have an index, let's say n. What this law is saying is that anytime you come across a situation like this, just write the base and then multiply the index. So example, so let's say we have 3 exponent 2, and then this 3 exponent 2 also have another index. It has another index, let's say 4. So what this law is saying is that just write the base and then multiply the index. So this will give us 3 as the base, and then 2 multiplied by 4, that is 8. Again, So why is this law also true? Using the same example, 3 index 2 exponent 4. This could be expressed as this. We have the index form, which is 3 exponent 2 being multiplied by itself 4 times. So it is being multiplied by itself 4 times. And then also from the first law of indices, when the bases are the same and then these bases are multiplied, or these indexes are multiplied, what do? We write one of the base and then add the exponents. So 2 plus 2 plus 2 plus 2, that is 8. So now let's look at the relationship between the indexes. Here the index is 2, is 4, you got 8. So now we have 2, 4, giving us 8. What operation sign must be placed between 2 and 4 to get to 8? So obviously that is multiplication. So all that this law is telling us is that anytime we come across a situation of this sort, we have an index with another power, there is no need for us to expand it to this form before we can get the final index number. No. Just write the base and then multiply the index and you get the right answer. So that makes it very easier for us. So you can see that when we familiarize ourselves with the laws of indices, it makes it easier for us to solve problems related to indices. So this brings us to the end of lesson 2. In lesson 3, we will look at properties of indices. Please like, comment, and share the video for others to benefit. Thanks for watching.